Scholars, let's talk very quickly about logarithmic functions. Logarithmic or log functions are functions of the form f of x equals log base b of x. Every time we have the log, folks, we have to have that b next to it. What is b? Well, b is the base, and the base has to be bigger than 0. It cannot be negative, or 0. It has to be always positive, and it cannot be 1. As in the exponential, we have the same issue with the logarithmic function. If b can be greater than 1 or between 0 and 1. If it's bigger than 1, it looks like this. If it's between 0 and 1, the function always looks like that. This guy is always 1, 0. 1, 0. Okay. Notice that regardless of either or, the domain is all positive numbers from 0 to infinity. Domain from 0 to infinity, and the range would be all real numbers from negative infinity to positive infinity. Yeah. It experiences a vertical asymptote, and that's it. So we always have the base, always a number. Since it's a beautiful relationship between the log and exponential. Of course, the functions are inverse of one another. And what's the relationship? Before I do that, let me define two special log functions. The natural log function. This is simply the log function base e, the number e. We'll talk about that in a few. And of course, we have the common log. The common log would be base 10. Okay, so if a natural log base e, that will be f of x equals, I'm going to write the mathematical sign now, log base e of x, but we never say log base e. That's a bad thing. We simply say ln of x, natural log x. That will be log base e. And of course, if I have a common log, which is base 10, it will be f of x equals log base 10 of x. I know the mathematical sign. If it's base 10, we don't write the base. This is simply log of x. So we always have a base, but if there is no number, what is your default? 10. And that happens all the time in math. If I have that, we're looking for the square root, right? We don't write the 2. That's your index, that's your default. The square root, that's your default. If I have, we don't say x to the 1, this one will be 1. We don't write the 1. Or 1x, the coefficient is 1. We don't write it. Okay, so those are the defaults. In this case, if I don't have a number, well, we always have a number. If it's not written, the base is 10. Okay? So, folks, we have, my students are always panicking with the log. Say, what is that log thing? Well, let's see what's going on. If I have the following, if I have, let me just do the following. I always start with a simple example. If I have 2 to the 3 equals 8, I can have two questions. How much is 2 to the 3? The answer will be, of course, 8. I can also ask 2 to the what? 2 to the what equals 8? The answer will be, of course, 3. So 2 to the 3 equals what? That will be an exponential question. 2 to the what equals 8? That will be a log question. So every time we talk about log, think of the exponent. As simple as that. Okay, the log, think of the exponent. So if I put the question mark here, right? Question mark, if I put a question mark, means what? The base 2, this is the base, right? 2 to the what equals, say, base 2 raised to what number equals 8. I don't know about you, but that's just too much blah, 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 blah. So I can simplify this as follows. Log base 2 of 8 equals what? The base 2 raised to what power will give me the number 8. Notice how this is not 2 to the 8, it's base 2 of 8. So in other words, what are we asking? 2 raised to what number equals 8, right? So 2 raised to what number equals 8? Of course, we know that the answer is 3. 2 to the 3 is 8. So that's what log means. Log represents the exponent. Okay, so now there is no more mystery. So if I have the following log base 5 of 25, so what is the answer here? I don't know. So 5 raised to what number gives me 25? 5 raised to what number equals 25? Of course, we know that the answer is 2. 5 squared equals 25. If I have log base 3 of, let me just do 27. 27 equals what? 3 raised to what number gives me 27? Well, we know that the answer will be 3. Why? Because 3 to the 3 equals 27. The base 3 raised to what number equals 27? Okay. But if I have log base, I don't know, base 4 of 1/4. Okay, that would be what? Let me just put here question mark. What are we asking? 4 raised to what number gives me 1/4? Well, we know, of course, that 4 to the negative 1 equals 1/4 to the 1, which is just 1/4. If I have, of course, log base of 1/16, that will be 4 to the negative 2, because that will be 1/4 to the 2, which is 1/16. Okay. Now let's use the common log. First, I'm going to break the rules. If I have log base 10 of 10, 10 raised to what number equals 10? The answer will be, of course, 1. We never write 10 to the 10, the log base 10, so we just simply say log of 10. The answer will be 1. 10 raised to the 1 equals 10. So I ask, what is log of 100? 10 to what number equals 100? The answer will be, of course, 2. 10 to the 2 is 100. 10 times 10. 1,000, that will be 3. 100,000, that will be 4, etc., right? So that's it. Now, if I ask you, what is log of 2, 3, 4? What are we asking? Every time I have the log, I'm asking for the exponent. The exponent of what? Of the base. In this case, what is my base? 10. 10 to what number gives me 2, 3, 4? Well, I know that 10 to the 0 is 1. 10 to the 1 is 10. 10 to the 2 is 100. 10 to the 3 is 1,000. I'm at 2, 3, 4. I'm here in the middle. So the number has to be 2 point something. Okay, at this point, I have no clue, but we can always use the calculator. Yeah. Okay, so notice we have 2 buttons here. Of course, we have log, which is the common log base 10. We have ln, log base e. So what am I doing here? Log of how much? 2, 3, 4. That equals to what? 2.36, as expected, between 2 and 3. That number represents what? Represent the exponent of the base 10, So if I do 10 and I raise it to that number, it better be 234. We can always try it. If I do 10 raised to that number, calculators are intelligent. In my calculator, the last answer is stored in here where it says 7, whatever. Of course, you just simply do log of 677. Ooh, difficult is that. That will be the exponent of what? Of 10 raised to that answer. Better be 677. Voila. If I try log of 2, what answer should I expect? If I do log of 0, if 1 is 1, I'm sorry, 10 to the 0 is 1, 10 to the 1 is 10. I mean, 2 yes, it will be 0 point something. Log of 2 equal to 0.3. Okay. What if I do log of 0.222? What number should I expect? It will be log of 0.222 equals negative 0.65. Okay. What if I do log of negative 10? What are we asking here? 10 raised to what number equals negative 10? That one has no solution. This is impossible. But of course, we know, as we said before, that the domain of the log is all positive numbers. Log doesn't like negative, log doesn't like 0. So if I try to do log of 0, the calculator will scream at me. It's an error of the domain. If I try to do log of negative 10, it will scream at me as well. Okay, because log doesn't like negative, doesn't like zeros, like the exponential. Okay. The ln works the same thing. So if I have ln of 2, well, let me just do a number bigger than, by the way, the number e, is approximately 2.71. Okay. Let me give you exactly what is e. So e of 4 is somewhere in between. I'm sorry, ln of 4, that would be e to what number gives me 4. The answer will be given the calculator. I'm still doing the, oh, sorry, I forgot to do something here. Let me share the calculator. I do apologize. Okay. Let me repeat what I just said. I just realized I was not sharing the calculator. If I do log of 0, that would be a domain error. That's a big no-no. If I do log, let me just clear this. If I do log of negative 10, that's also an error. Domain error, it's not possible for the log to take negative or 0. And how much is e, the number e? Let me just clear this junk. E to the 1, 2.71. Okay, sorry about that, I forgot to share the calculator. So if I ask you how much is ln of 4, the answer will be whatever. So what are we asking? E to the whatever will give you 4. So let's see, what do I have? If I do ln of 4 is 0.38. So if I do e to 1.38, will give me 4. If I do e, I can always do second ln, that get e raised to the answer that I got, better be 4. If I do ln of, I don't know, 333, I have no idea how much is that. We'll just simply use the calculator. 3, that would be that. 5.80, If I do e raised to this number, 5.80 something, I do second answer, that will give me 33, I hope. Voila. Okay. So very quick introduction, folks. What is the log? They're inverse functions. And also the domain of one is a range of the other, as we learn the theory of inverse functions. And we use one to solve for the other. If I have log of x plus 3 equals 2, how do I solve for x? Well, I know that what's the base here? I know there's invisible 10 here. 10 here. So what do? I quickly convert to exponential. 10 to the 2 equals that. So let me stop sharing. Okay, so this is just a quick introduction to solving equations. So the base 10, which we don't write in this case, raised to the 2 equals x plus 3. But 10 to the 2, of course, is 100 equals x plus 3. We subtract 3, x equals 97. We solve our first logarithmic equation. Okay. If I have 10 to the x equals 77, what do I know? If I'm looking for the exponent, I know that log of 77 equals x, because after all, x represents the exponent. It's an invisible 10 here, 10 to the x equals 77. So I just simply use the calculator. I'm not going to share. You just simply press log of 77, and you will get 7. You get just about 1.88. In this case, x is approximately 1.886. That's good enough. Okay, so if I do 10, what did I do here? Yeah, if I do 10 and I raise it to this number, let it be 77. Okay, thank you.